All right, so let's look at this example that I promised. In Z adjoin X, X is not maximal. Well, why is that? Well, X is contained in the ideal generated by X in 2 that we saw a while ago, and it's very much not equal to the ideal generated by X in 2. Because, as we saw, these are sort of polynomials of positive degree. And this is polynomials of positive degree. But we are also allowed some constant terms with even constant term. So the constant term for this guy is on the left is 0. So the guy on the right is bigger because we can have some constant terms. They just have to be even. But since they have to be even constant terms, this is not the whole ring. Okay, so there's an ideal that sits in between X and Z adjoin X. In fact, there are lots of ideals that sit in between X and Z adjoin X. So X is contained in, and again not equal to, X comma M. And provided M is not plus or minus 1, so for M not equal to plus or minus 1, all of these ideals sit in between X and Z adjoin X. It's not only is X like not maximal, but if we were to try to draw a picture here, there's like X2, X3, X4, X5, and so on, and then Z adjoin X above it. Let me just draw lines for subset containment because that's easier. So there's lots of things in between X and Z adjoin X. Let me also observe something. X is a prime ideal. Now, X itself is irreducible, and we know that if we have a PID, a principal ideal domain, then irreducible is going to tell us prime, and so therefore prime ideal. But the problem here, so let's put a caution symbol. I realize my caution symbol is the same as my remark, but I'm too far in. So this, what's the caution? The caution is Z adjoin X is not a PID. Why? Well, that example I showed you a while ago, this ideal X2 is not principally generated. So this is an example of not a PID. So we can't use that argument that like X is irreducible. That's not going to guarantee that this guy is a prime element anymore. However, our proof of this statement that X is a prime ideal is I made us mod out by this ideal already before in anticipation for this moment. And we saw that when you mod out by this ideal, you get Z, which is a domain. And whenever you mod out by an ideal and you get a domain, it must have been a prime ideal. Okay, so let's just recap here. This is an ideal which is prime. It is very much not maximal. There's lots of ideals in between us and the whole ring. So it's a prime ideal which is non-maximal, and we had to go somewhere which was not a PID to find such a thing.